Science Beetle.
Hey, welcome back. In this lesson, what I want to go ahead and cover is percent yield. And so I'm going to provide some problems for you that you can use to practice your percent yield skills. And so let's just go ahead and dive right in, and let me go ahead and bring up a sample problem. I'll put it on the screen, and then we'll begin solving this problem. Okay? So the problem here tells us that we have a balanced equation identified here at the bottom, and I'm going to go ahead and underline it. So the balance equation is here, and it says if the reaction of 69.2 grams of H3BO3 produces 70.1% yield, how many grams of H2O would be produced from this reaction? Well, what we first have to do here is identify what is the given and what it is we're looking for. So let's go ahead and do that. And I'm going to identify the given here at the bottom. I'm going to just color code it in blue. So one of the given is that we produce a 70.1% yield. And so that's one of the givens. Then the other given is going to be the 69.2 grams of H3BO3. And also, granted, the equation is given to us. Those are three pieces of information that are given to us. Now, keep in mind that in order to solve these percent yield problems, we need to recall the percent yield equation. And that equation is the following. And so the equation here is actual divided by theoretical times 100 is going to give you the percent. And so in the problem that we've got here, the actual is really not given necessarily. In fact, what they tell us is that we need to find how many grams of H2O would be produced. That's actually the amount that actually gets produced from this equation. What we are given is 69.2 grams of H3BO3, and from that we're going to be able to derive the theoretical, or what we would expect to get. Another way of thinking of the actual and the theoretical is the theoretical is what you expect, and the actual is what you observe in the reaction. And so let's go ahead and figure out from this equation, if we take the 69.2 grams of H3BO3, let's go ahead and figure out how many moles of that is, and then from there we'll try to figure out how many moles of water it is, and then how many grams that is, because our initial problem here is given in grams. Okay, so let's go ahead and begin that work. So we begin with 69.2 grams of H3BO3, and in order to find out how many moles this is, we're going to multiply by the molar mass. And we know that 1 mole of H3BO3 contains 61.81 grams of H3BO3. And so when we do this, the 8 grams are going to cancel, and what we're going to be left with is going to be moles. And in this case, if we carry this calculation out, the answer that we get is, and so you form 1.12 moles of H3BO3. And so since we're trying to go from here all the way over here, we need to get a mole ratio. Now if we do the mole ratio, what we find is, and I'm just going to go ahead and move this section here, I'm going to go ahead and move it to the very beginning over here. So let me write it here. And I multiply that by the ratio, and I know that 6 moles of H3BO3 is going to react or decompose in this particular case to form 7 moles of H2O. So the moles of H3BO3 cancel, and what I'm left with is the moles of H2O. And that comes out to 1.306 moles of H2O. Now keep in mind that our original problem was in grams, so we need to take this a step further and multiply this by the molar mass of water. We know that 1 mole of water is going to have 18 grams of water. And when we carry this out, our grams or moles of water cancel here, and what we're left with is grams of water, and that answer would be 23.508 grams of H2O. Now, this number here that we've calculated is going to be the theoretical or the expected. And so when we plug it back into the equation that we have here at the very top in terms of the actual divided by theoretical times 100 equals the percentage, we got to take the information that they gave us and plug it back into that equation. And so let me work this here at the very bottom, and we'll substitute the equation for us. And so I've rewritten the problem, the actual divided by theoretical times 100 equals the percentage down here. And what I'm going to do is I'm just going to go ahead and replace the information that we had from the given into this equation now. And so if I begin with a percentage, I know that at the very beginning we started, our equation produced 70.1%, and I illustrate here in purple. And then we just calculated the 23.508 grams, and that goes into theoretical. And so let me replace that. And so we get this. So in order for us to solve for the actual in this equation, then we would need to divide by 100, and we do that here. And if we do that to the one side, we have to do it to the other. And when we do that, the hundreds cancel here, and this particular number, 70.1% divided by 100, that turns into a decimal. And that decimal then becomes 70.701. And or in other words, move the decimal over 2 spaces, and it gives us 0.701. Since the hundreds on the left side disappear, I'm going to go ahead and erase those because they're no longer there. And what we're left with is a simplified equation of actual divided by 20.508 equals 0.701. And so in order for us to get rid of the 23.508 on the other side, we have to multiply by that number. And so I'll go ahead and do that here. And so if we do that, it doesn't fit, but I just put it here just to the left. And when we do that, the 23.501 cancels on this side. And what we do to one side, we have to do the other. And actually, this is 508. And so we do the other side, 23.508 grams of H2O. And so what happens there, if you multiply those two together, what you wind up getting is, and the result here would be 16.47 grams of water would be produced when 69.2 grams of H3BO3 results in a 70.1% yield. And so the answer here is, again, here, 16.47. So that's one example. In the next lesson, I'm going to go ahead and provide you another example. So just give you some more practice, and we'll run through it, and then we'll go from there.